My name is Sandro Balpano. I'm a senior design engineer for Davenport Machine. And on behalf of all the crew at Davenport, I'd like to thank you for your attendance today at our machine demo. Hopefully that helps out with the volume. Is that going to work? All right, thank you. So, this is the Davenport Hybrid machine. It's our platinum platform, the latest and greatest available from Davenport. It combines intuitive CNC control and precision, along with the mechanical versatility and dependability that you'd expect from Davenport machine. It solves a lot of the major challenges facing the precision parts industry, whether it be constraints on part size, part quality, the ability to hold tolerances. There's a lot of features in this machine that are going to help you guys deliver what your customers are expecting. And it's going to do all that with a superior return on investment for your dollars. So compared to other platforms, we've taken a look at the challenges that face our industries. You're expected to deliver smaller batches of precision parts out of tougher materials. You're expected to do it in shorter lead times, and you're expected to do it with workforces which are getting older and retiring and being replaced by people that don't necessarily have all the mechanical skills that previous generations had. But they're coming to you with a different skill set, and it's different. It's not worse, it's just different. So we're taking a look at all the things that the Davenport was able to bring to the table and trying to adapt it to the challenges that are facing you. So part of the design philosophy that we employed here at Davenport was taking a look at it from our customer's perspective. We're trying to drive up profits and productivity. So we took a look at every system in the Davenport machine, every mechanical system, everything that leads to either downtime or leads to part inaccuracies, and we looked at ways to improve that, to make it simpler to run, to make better parts, and to make it more profitable for you to run your parts on a Davenport. Many of the changes here, they're small changes. We pick it off a 10th on tolerance here, a 10th on tolerance there, but taken together, we took a holistic approach to this, and all those changes taken together had a drastic effect on the ability of this machine to deliver for you and your customers. We're going to take a look at some of those fundamental changes in this machine right now. So the way a Davenport works, it's a multi-spindle. It's making 5 parts simultaneously. There are up to 10 tools engaged in the bar simultaneously making chips. What that does for you is our average cycle times are somewhere between 2 and 4 seconds. In order to do that, those 5 spindles, are held on a revolving carrier. It looks a lot like a Gatling gun. There's 5 tubes making 5 parts, and they index between tool positions. On this machine, one of the major changes has been that the spindle carrier is held in a set of angular contact ball bearings in the machine base. So compared to older machine platforms, any inaccuracies that you would get by the spindle carrier moving around in the machine base have been eliminated. We get better length control, we get better process control, better surface finishes, better diameter control on your parts. All those things taken together help you make better components, help increase your productivity and your profitability. All of our radial infeed positions, so on a screw machine like this, tools either come in from the side and work on the outside of the part, or come in from the end to do drilling and reaming operations. All of the radial infeed positions are CNC controlled on this machine. In 4th position, which is the one up on top, there's actually a 2-axis CNC control. So that particular slide can not only move in and out on diameter, but it can also move left to right to do length control as well. Along with some of the other changes that are in the machine, one of the things that you're going to notice because of that CNC control we can predict where a tool goes to within about 50 millionths of an inch every single cycle. So the changes that we've done to the revolving head and to the spindles allow us to predict very accurately where the part is going to be every cycle. And the changes that we made to the CNC slides allowed us to predict very accurately where the tools are going to be on every cycle. Those two things combined together give you your precision and your repeatability on your machine. Along with that, we have new tool holder options. These tools are designed to use cutting-edge technology available from all the major insert manufacturers. Carbide disposable inserts, very repeatable, long-lasting, and the tool holders that are in there are rigid and repeatable as well. They allow you to minimize the amount of time that the machine is down while you're doing tool changes and get back up and running good part production in as little time as possible. All of them are also ported for high pressure coolant. This way you do get the lubricity right to the cutting edge to make sure that those tools that are in the machine last as long as possible. So as far as insert options, you take a look at the screen here, you have a variety of different shapes of inserts that are available for you for skiving, forming, cutoff, and parting operations from, like I said, major carbide manufacturers. We're not in the business of providing tools for you. We want you guys to be able to use the latest and greatest technology that is available out there, along with the different grades of carbides available from the ISCARs and Continentals of the world and other companies like them. You have a lot of options available to you as far as tool coating, which really helps increase the life and longevity of your tool and helps you maintain the good surface finishes that you need for the parts that are being asked of you today. So one of the most exciting features on this machine is that it's the first generation of Davenport that has digital size control. Previous generations, if you wanted to make a change in size, you had to shut the machine down, open up the enclosures, get in there with mechanical tools and start making adjustments. And it was a difficult operation which required a lot of skill, and you know, it was very easy to overshoot the target and then have to go back in there and make additional adjustments. This is the first machine where you can measure parts as the machine is running. You can go up to the control and with a couple quick clicks get yourself to an area where you can put in a number that you want to change that part by. Publish that to the drives, and as the machine is running, the very next part will be a little bit bigger, a little bit smaller. Part of the new control here, you'll see a 15-inch color touchscreen monitor. You know, nowadays everybody is used to touchscreens. Everyone has a smartphone, an iPad at home. It's the way that we expect to interface with our technology. So the ability to walk up to a machine, get a lot of information presented to you in something that's easy to read and dynamic, and being able to flip between screens with just a touch of a button is a huge advancement over previous generations of machines. It has a full Qwerty keyboard right there at the control. You can program here. You can also program offline and download programs to the machine. Both of them are available for you. We also have remote hand wheels available on the machine, so that as you're trying to jog your various CNC axes, you can use the hand wheel to control a multitude of functions on the machine. So the control technology is not just a pretty face. Back in the control cabinet, there's a lot of work went into making sure that this is the most energy efficient machine that we've ever built. All of these drives are built on high voltage backplane, which allows you to get very high performance out of your motors. They get to be very snappy. They accelerate quickly, decelerate quickly, much more so than older generations. They're also voltage on demand. So as you need the power, it consumes the power, but it doesn't waste power in the form of heat energy. And when you need to slow the machine down, it regeneratively brakes, so it converts that back into electricity that it feeds back onto the backplane. It doesn't waste it as heat. One of the nice side effects of doing that, not only is the machine using 50% less electricity to do the same cuts than it used to, but it's not generating the heat that you need to now take out of your plant using air conditioners and blowers and things of that nature. So you get to save the cost on your electricity twice. And the reduction in heat that's being generated also helps to maintain a more thermally stable platform. So as you're generating parts, heat isn't affecting your part quality. So when we designed the controls, we took a lot of effort to make sure that not only did we have traditional Davenport operators working with us to design the controls so that it would be intuitive to somebody that's worked on our machines for the last 20 or 30 years, but we also put a lot of effort into making sure that people that aren't familiar with these machines could quickly walk up here and make the adjustments they need to get parts running, up and running quickly. We actually hired operators with little to no experience on these machines, simply to get their feedback as to what makes sense to you when you want to run this. How can we make it easy for you to get rid of some of the mechanical adjustments and get parts dialed in tolerance. At Davenport, we have Davenport Machining University. We have a track record of graduating over 100 students with the ability to not only run the machine but maintain them. It's been so successful, we've used it internally to train our own workforce. We're very confident that we have the ability to take anybody that has the desire to learn one of these machines and make them an expert in running this machine. So when you guys are considering this, and if you're thinking that training is your limiting option, it is not. It's something that can be picked up. We have a good track record of doing so, and we're more than happy to help you out. Short little video here to show just how quick and easy it is to make sure that all your parts are running in tolerance. You see, he took 5 parts off of the machine, measured them, and in a matter of seconds can go into an offset page, tell each of the spindles how big the part was that he put in, so that the very next time that he starts making parts, all 5 spindles will be producing parts of the same size. There are no turnbuckle adjustments necessary for this. There's no tool post stop left in the machine. All of that has been obsoleted and completely replaced by a quick, easy push-button digital option. Talking a little bit about the 2-axis slide. So up in the upper position here of the machine, that tool holder is just like a 2-axis CNC lathe. It's capable of doing single point turning, contouring of the outside of a part, single point threading. Anything that you can do with a typical CNC lathe, you can do with the one tool in that position. On this machine, we also are showcasing the ability to not only do OD turning, but ID tooling with the exact same slide. So we're turning a groove on the outside of the part, and then we're taking a bore bar and putting it on the inside of a part to deburr a cross hole that's on this. And we're doing it all in one tooling position. That still allows us to have 9 open tools to do the remainder of the features on that particular part. This graph that you see up on the monitor here is a great example of the differences between older Davenport machine platforms and this new one. We took the same part, same material, same tools, and made that part in all 3 generations of our machines. And you can see the Model B, which is the older cam-driven machine, has a relatively wide and flat distribution. So the parts that came off of that machine, all 800 that were in that run, we were able to get them to within 4 thousandths of one another. When we stepped up to our HP machine, which utilizes ball bearing technology on the spindles, you can see that the distribution got a little bit narrower, and we were able to take more of those parts and put them in a tighter range. So only 2 thousandths or so variation between those parts. But when that same test was run on the hybrid, there's almost a 10-fold increase in accuracy and precision over older Davenports that some of you may be used to dealing with. That's a massive leap in the ability to make difficult components on your machine platforms. So one of the reasons for that control is that we've eliminated the need for shave tools on this machine. Shave tools are a way to compensate for mechanical inaccuracy in a machine, and most multi-spindles use a shave tool of one form or another. They work great, but they're a real pain to set up. It takes a lot of finesse, a lot of skill to get it to be just right, and then as the tool wears, they're not easy to adjust and keep everything running properly. Well, because we have digital size control, the shave tools are no longer necessary. So the setup skill that's required for this machine, roughly 30% of it was all centered around making the adjustments that are on this tool. And being able to eliminate this tool from the mix makes this machine that much easier to use. Another big issue that we had in the field is chip evacuation. So a lot of parts nowadays are made out of much more difficult to machine materials. Lead is being taken out of a lot of the materials that you typically see being used on these parts, which makes it difficult to break a chip. They get stringy, they get all balled up inside the machine. Chip evacuation was a major concern for multi-spindle users. In order to address that in this machine, not only is the machine longer, so the area in the workspace is wider than it has been before, but we've gotten rid of a lot of the obstacles that are in the way. So as you are generating chips, with the CNC controls, you got a lot more options as far as putting chip breakers in to make your chips smaller, and they also don't have as many places to hang up on the inside of the machine. So they all end up working their way down into the chip conveyor and being carried out of the machine much more effectively. It lets you have longer unattended runs without the interruption of having to stop the machine and get out a pair of pliers and clean the thing out. So the chip conveyor is down inside the pan area. And unlike older models of the machine that only had a narrow 4-inch wide trough to carry chips out of the machine, this is a 22-inch wide conveyor. It spans the entire bottom of the machine, and everything's been redesigned so that it washes down. As chips are being generated and flung around on the inside of this machine, the oil washes it down into the chip conveyor and carries it out. Again, it allows for longer interrupted runs without having to shut down the machine and having operators tend to cleaning as opposed to tend to machining on these machines. The entire machine base has been redesigned. So the previous platform had about a 60 or 70 gallon capacity at tops. This machine base is well over 200 gallons. So it's roughly 3 times the volume of oil in this machine than in previous generations. One of the nice benefits of having that much oil is that you're very thermally stable. As you're generating heat and making the cut and your oil temperatures would go up, you'd have trouble holding size and finish tolerances on your part. But now with 300 gallons of oil in this machine, over the span of hours, the temperature in the machine stays a lot more stable and your process in general stays a lot more stable. Your oil stays the same viscosity, it acts the same way when you start and finish a shift, and your parts end up just looking better overall. Some of the other major changes that we made are to the casting itself. So the picture above me is of a raw casting before it gets machined and before it has all the other 3,000 parts bolted to it. But because we were able to eliminate some of the mechanical complexity in this machine, we added material to areas that were generally thinner. That beefed up everything and allows us to make much more aggressive cuts and still have the rigidity in the machine casting to be able to handle that. So the revolving head itself, so the spindle carrier, is based primarily on what we call HP spindle technology. It's been around for about 10 years in some of our older platforms. Right now there's 200 of the HP heads out in the field. The combined total service life of those 200 heads is 1,600 years. So that's how long they've been in operation. During that time, they've run roughly 3 million hours. And because this machine is capable of making several thousand parts an hour, you can just imagine the number of parts that those 200 HP heads have achieved. During the lifetime of those HP heads, more than 80% of them have never required any maintenance whatsoever. Bearings have not been replaced, spindles have not needed to be reconditioned. They just run and they run forever. In the hybrid, we've taken that head, put it in a bearing like we've talked about earlier, and it's basically an upgraded version of an HP head running inside this machine. It is available in both 5/8 diameter and 7/8 diameter capacities, and it's available not only with aligning gears, which would have the spindles always spinning, or in spindle stopping versions, so that you can stop a spindle to do cross holes and other features where you don't want that spindle turning. So to address some of the more difficult materials in this machine, we've added high pressure coolant. It was never really an option before on any of our machines, but now we have a combination of 30 gallons per minute of low pressure coolant, and an additional 8 to 10.5 gallons per minute of high pressure coolant. There's 8 ports in this machine that can be turned on and off at any point, and all the tools in this machine are capable of having high pressure coolant ported to them. For some of the more difficult aerospace materials, having high pressure coolant at the cutting edge is critical to making sure that your tool lasts past part number 1. Some of the other standard machine upgrades that we started going through in this machine, the lighting was a big deal for us. Older versions of the machine, it was a little bit difficult to see inside there. We've upgraded that with 4 banks of extremely bright LED lighting. There are no shadows in the work zone. It's easy to get in there and make the adjustments that you need to and see what you're talking about, what you're doing. The machine in general is a lot quieter. We've eliminated a lot of the gear meshes in the machine, so the decibel level has dropped almost 10 decibels from previous generations. That's the equivalent of having to have a conversation next to a lawnmower that's running versus having a conversation in your kitchen next to a dishwasher that's running. You can actually talk to somebody now and have them hear you while this machine is running. Some of the other things that we did, upgraded the mist collector to make sure that the air quality in your shop is as good as it can be. And we've added automatic fire suppression to this machine as a standard option. There's a lot of tools in there, especially with carbide. We wanted to make sure there was no chance that if you did get a fire that it got out of control, automatically we'll put that fire out in this machine. So the types of parts that are being run on this machine, what was it targeted for? Difficult materials, difficult geometries, difficult surface finishes and tolerances, things that you would not necessarily think of producing on a Davenport before, for one reason or another. This machine is capable of doing so much more than our previous platforms. It's going to take a reevaluation of what you can and can't do on a Davenport Hybrid. We believe that this machine will outproduce any multi-spindle on the market right now. We make parts in less time than most machines out there take to index from one spindle to another. So we make parts while other machines are thinking about changing from one spindle position to another. We can make parts faster and we can do it more cost effectively than many of the machines that are out on that market right now. When you start looking at things, like the hydraulics industry, some of the complex geometry and the tight surface finishes that they need on their parts, this machine is capable of doing things like that. The electronics industry, very high volume, very high material removal rates on some of these things. And some of the parts are really tiny. I mean, there are parts that look smaller than the chips that you're normally used to seeing coming off of other machines. We can do that kind of thing, and we can do it successfully on this new machine platform. And most importantly, the aerospace industry. Some of the materials that go onto fasteners that hold together the airplanes that you guys ride in are about the nastiest things that you can machine. And in previous generations of our machine platforms, they were just too difficult to machine. But this machine was designed specifically to address those concerns. And the successful runoffs that we've done for the aerospace industry show that we can make these parts, we can make them faster than our competitors, and we can do them more cost effectively. That pretty much concludes our presentation today. If any of you have any questions, I'd be happy to take them. And if you stick around a little bit later, we'll be running the machine and we'll show you parts coming off of this and exactly what the machine can do.